Good morning. I'm sorry I made you wake up this early to applaud an Intel guy. I know that's a little unusual, but bear with me because that's actually not what I'm here to talk about. I have been with Intel for some time doing engagement on UEFI, but I'm here to talk about more of the work that I'm doing with the open source side. I've recently moved into the position of Community Evangelist for TianoCore, which is our open source implementation for UEFI. So I want to talk more about that and less about what I actually do for a living with the little chips, with the guys in the suits, because I'm a software guy. What I do want to talk about is first, just an introduction, a little bit of a background on why we're doing standardized firmware, why that might be a good thing. Second, I want to focus more on the recent changes that we've made to TianoCore, governance, stewardship, code check-ins, changes in source control, plans for the future. If there's a community evangelist, we must be talking to people about stuff we want to do. Turns out we have things we want to do. And finally, a lot of folks don't kind of understand some of the history that I've come from with firmware in the PC industry. So I want to kind of talk about why I think firmware is important and why as a marketing person, I spend all my days working on something that if it works perfectly, nobody ever sees. This may have been a bad career choice, but it got me to a keynote, so I think I'm doing okay. First, let's go with the introduction. TianoCore is the name of the project we use for supporting the EFI development kit, EDK, now in its second generation. It is from about 2004. Oh, look, the streaming works. That's good. So we're supporting a BSD open source implementation of UEFI. And our mission is to improve our contributions to the community, improve the code quality. We're trying to go for a product quality tree. We're also trying to provide regular updates. The whole point of open source is to show your work even before it's finished, which is a little embarrassing for some people. But we are trying to work on that and provide more end-to-end solutions. Firmware is designed to bring up a platform. If you don't have platforms, how do you prove the firmware works? So we're actually trying to make sure that people can go and get commercially available solutions, pull down firmware, build their own variations of that, and prove out whatever concepts they need in their firmware variations. My vision personally is more activity in EDK II. This is something that I was actually kind of critical of in our own people for a certain amount of time, that we didn't have enough outside contribution. For a long period of time, this was very much where Intel worked on Intel things and put Intel code into open source. I used to write for Linux.com. I kind of have an idea what we should be doing in open source, and I'm trying to make sure we push towards something that's more transparent and that's more community-driven and actually has a wider variety of solutions. Okay, BIOS. Blame it on software. No, basic input-output system. The good about this was the original bottom layer that the IBM PC put out. So a bunch of guys in Boca Raton, Florida, early 80s, decided they were going to build a personal computer. It might have got laughed at a little bit, but they sold a few units. They were supposed to sell 250,000 for the run. They might have done a little bit better than that. They accidentally kind of created an offshoot of the industry. That bottom layer, their basic input-output system, was what abstracted the operating system from the hardware. Now that sounds like a basic concept, but if you were doing computing in the late 70s, early 80s, you didn't have that. You had machine-specific boot code, bootstraps, written to machine-specific operating systems. This was the mainframe model that IBM made a lot of money off of and ended up, through the personal computing model, trying to break a little bit. One of the nice things about it was that you could change the operating system without changing the underlying boot layer. You could change the boot layer and still be compatible with the existing operating system. So this is why the gentleman in the front row was able to write his own OS and sort of start another kind of revolution, but I'm not here to talk about that. He does a much better job. If you added an expansion card, turns out it carried its own initialization driver. The bottom layer of firmware didn't need to know about that. It just needed to know how to talk to that option ROM. So if you added, back in the day, a second floppy drive, ooh, that may carry its container, tell you how to initialize it. You added the whopping 10 megabyte hard drive. You added the controller that may have had its own init code for that. It was ubiquitous. So when Compaq decided to black box engineer it or read the magic purple book, which had all the assembly instructions and jump tables printed in it, they were able to replicate it to a point that they could run the same operating systems they did. Then somebody else replicated that, somebody else replicated that. A guy from India moved to the US, started a company called AMI, gave me a job for 15 years. I am onshore insourcing. It works. So that was nice. What was kind of terrible about it? We kept using it for better part of 3 decades, and it was a 16-bit assembly model because on the 8086, 8088, that's what you ran. You had a whopping megabyte of memory, and you didn't even use all of it. Some of it was reserved for this boot code and the expansion ROMs. It was supposed to be extensible, except for the points where it never left that 16-bit operating model. So your modern, Intel Core i7-5930K processor, I know that because I own one. I didn't memorize our entire chart. I'm a software guy. That starts out in 16-bit mode, in real mode, and then eventually has to jump into a protected mode. I've heard it called owning a Porsche that starts out as a Yugo until it hits the end of the driveway. Not the best model in the world. So it's hard to expand on that where you have to factor in compatibility for something that has almost an order of magnitude fewer bits in its native operating mode. It wasn't standardized. Yes, there's a document you can find on the internet written in HTML 1 point something that has all of the different extension codes compiled, but that wasn't standardized and agreed on. That's sort of harvested knowledge. You had to know a guy who knew a guy who knew a really old guy who wrote all this stuff and had it either memorized or written down somewhere. And it did not have a concept of openness. The thing we try to do through UEFI, Unified Extensible Firmware Interface, is to fix these 3 things. 1, we don't lock the model to a particular architecture. 2, there's an extensibility concept through protocols and standardization. And then the open part is not part of UEFI. UEFI focuses on the standard. TianoCore is one implementation of that. It's not endorsed by the UEFI form, even though a lot of the same people who work on the form and contributed to the early days of the spec are also contributing to this. They are considered 2 separate things. If somebody comes out with another open form of UEFI, woohoo, great. Okay, I have heard this so many times. We already had something that worked, Brian. Why don't we just patch it? Did I mention I worked at a BIOS company for 15 years? The first 5 of mine looked a little like this. I hope that most of the code I wrote in those days is gone out of circulation. It's assembly code. I'm basically like grunting at the machines or yelling 0 and 1 at Siri and hoping it gets them in the right order when it compiles. This is probably not a good way to build an industry. This might work for a one-off product, but when you try to expand or if you build something and say, I built it for this version of the Linux kernel, and somebody comes along and says, that's great, I want to buy your board and run FreeBSD on it, and you haven't worked that out in your loader, that's a competitive issue. Okay, standardization is supremely important. There are a lot of times where ad hoc things turn into standards, or people start from standards in the beginning. What is good is that you come up with a process, you document it, and you have the ability to add people to it and add their ideas to it. This picture I took in Germany about 6 years ago. You have those random animals you drop into a city. Atlanta had cows for some reason. There were dolphins, and artists would paint them up and mock them up. And this is kind of my reminder to our engineers what happens when you don't like spec out a project before you start. It turns out kind of looking like whatever this animal is supposed to be. So this is my standards Patronus. Okay, specifications. I'm not going to read these to you. The coffee hasn't kicked in yet. They're really big. They scare people because they're really big, but we wrote everything down, so we don't have to remember it. We just have to remember where to find it, which is uefi.org. So there's the UEFI specification, currently in 2.6 revision, and that is the layer between the operating system and the firmware. It doesn't dictate how the firmware is built. So this interface could be on a commercial BIOS, could be on open source, it could be a core boot or U-boot payload. Then there's ACPI underneath that. And then the platform initialization, which is how the modules underneath communicate. If you're going to build UEFI all the way down, then PI dictates how silicon modules talk to silicon modules, or how silicon modules talk to dispatchers. Packaging is how you put those things together in a way that someone else can consume it. If you're going to distribute binaries that somebody wraps UEFI around, either in a closed or open source way, PI dictates that. And then there is a shell. The shell is just kind of a rudimentary DOS-like, BSD-like thing that just allows you to run utilities It's really meant as a pre-production environment. Some people do ship the shell with their platforms, but that's less and less of a thing these days. It's really more of an environment if I want to run tests, if I want to automate my production systems. Okay, recent changes. First of all, EDK II and TianoCore started out as an Intel initiative. In the early days of moving EFI from an internal Intel document to an industry standard, we decided to open source a large portion of the code. If you've gone to one of my far too numerous sessions at IDF, or if you've gone to another UEFI specification presentation, you've seen this thing called the big green H. This is the first time I've given a UEFI presentation in a long time that doesn't have the big green H in it. I know a lot of you are tired of it, but it's this idea that you have this framework and that the framework is open and that components at the top end or the bottom end sort of fit into the space in the H. Moving into more of a standards environment, we recently decided that TianoCore needed to follow a more open governance model. It shouldn't be a thing that Intel is fully policing and controlling. That's not open, that's just releasing your code after you're done. So Leaf, who's sitting in the front row here from Lenaro, Michael Kinney, who's a principal engineer at Intel, and Andrew Fish, who is one of the UEFI and EFI architects who moved over to Apple many years ago, are essentially the community maintainers. So they're handling all the technical stuff. I stand on stage in front of pretty lights and point at PowerPoint and encourage people to use the things that they're working on. We moved to Git. Oh, thank goodness, I love Git. This helps with a lot of things. One, it got us off of a platform that shall not be named unless I'm at a bar that was having some issues and wasn't probably the best thing for us to be using. Second, Git helps us with a lot of things I'm going to talk about in a few minutes as far as doing staging branches and taking private contributions in code before they're IP clean and merging them into the main branch. It also happens to be some of my friends' work, so yay, they get to keep their jobs. Our staging branch workflow, which I alluded to mere seconds ago, we want to keep the main branch focused on becoming a product quality implementation. That is where the stable things live. So, but we still want to work in the open, so staging branches are a great way to work on this. Let's take boot through HTTP through TLS. Yay, secure boot. That doesn't happen to happen on like a PXE system, so I can do it outside of my network. I have gold status on 2 airlines. Recovering my notebook outside of a corporate environment is extremely important to me. I would like that to be able to happen in case it ever comes up. So I want this to work. We're not going to put that into the main branch until we're sure it works. We have a pretty good solution right now. You can run SUSE on it fairly well. They have stuff in their open branch that's compatible with it. We went to a Plugfest. We found problems. Glad I didn't ship with those. Once that's done and goes through its normal contribution and review practice, that's going to get merged into the main tree. So that allows, again, our main tree to be focused on what people are doing. They'd rely on it as a product. They're going to want to pull from the non-staging branches for their product quality code. Okay. File allocation table, the FAT. Oh, Linux people love FAT. Yay. So let me give a little background about why this is super important. One thing that UEFI specifies is a transition of disk structure. Master boot record, MBR, was the structure that was used from the early PC days all the way up. It is what legacy BIOS boots to. It is a magic sector of your drive that has magic bits on it that tell you, literally, this is a place that you jump to. It was written by assembly programmers in Florida 30+ years ago. So their idea was you just tell this to jump to a place in memory and you'll boot the OS. Now trust me, if I walk off the stage and I don't know where the stage ends, I'm not just gonna like wander off and go, I'm just gonna go to the casino, right? I need to know where that barrier is. So just blindly jumping into code is why we had boot sector viruses, yay, and lots of other problems. The MBR wasn't redundant. If that first block of the disk got cut off, if you typed format C:/S, hit enter, went oops, and hit Control C, your disk is already gone unless you have a good recovery tool, because that gets blown away. There's no backup copy. So we moved to GPT. Bigger disks, 9.8 zettabytes, which I can't even fathom as a storage. But it also changed the boot structure for UEFI. Instead of having a magic sector, you have a defined service partition. And at the time, we wanted to use kind of the simplest, dumbest thing that was available, which was FAT. the licensing restrictions sort of started to kick in. And when people do emulators, now the emulator is shipping on a system. There is a FAT license that was already in agreement for UEFI that said, oh, if you're using it for a boot sector, no problem. You can ship FAT with no issue. Just don't use it to format anything else. And once you put it in that container on the simulator, you were outside of that license. So the simulators all used CBIOS. Yay, not what I'm working on. So changing this is a very big deal, not only for Linux, but things like OVMF, which we rely on within UEFI to do a lot of simulation before we ship. So as of this March, Microsoft removed the use clause from UEFI FAT sources. For anyone who's not a lawyer, that means that there's no restriction of use, and it's just two-clause BSD, which means in even less terms, you can take it and work on it. You don't have to give it back. Sorry about that. That wasn't my choice. Okay, LLVM and clang. Some people call it C-lang. I think clang sounds cooler. Clang. It's a good word. We've been supporting GCC for a while, mostly in the 4.x branches. We haven't been shipping it a lot because we didn't really have it optimized very well, and the binary sizes were kind of embarrassingly large, like they wouldn't fit into the flash part. So a lot of our reliance and validation has been done on Visual Studio. Just don't boo people listening on the internet, just boo inside. It's cool. A couple of reasons why we went to LLVM and GCC 5.3. One, yay community. Two, I don't like relying on a single tree of compilers. I used to do a lot of testing work, validation nuts, so I like making sure I have options. Also, these two tools have link time optimization, which gets your binary sizes, within reason, and also allows you to do a lot of cool static analysis. The Clang analyzer is something we're going to be working with a lot more in the future. Static analysis allows you to find stupid programming mistakes. You can do security scans on code before you ship it to millions of people. Good thing I'm in this conference in Vegas and not a different conference in Vegas watching someone talk about my work. And we did a lot of this on Linux because that's where these compiler tools work best. My hope going forward is that something like LLVM becomes the standard compiler across different operating systems. That's another advantage it really gives us. GCC works really best in a Linux environment, which means if you don't have a good way to replicate that chain on Windows, then you can't do cross-validation. But if I have a single compiler that goes across different operating systems, then I have a much stronger way of saying, yeah, I'm sure that when I build this over here, it's also going to build over there, and everyone has a consistent experience. All right, sizes. We did a lot of experiments on this. There's two particular results I want to point out. One is for OVMF, which is the emulator we use generically. And these are compared to Visual Studio 2015. Both of these cases have link time optimization enabled. Clang actually was doing better than Visual Studio was, which has been, Visual Studio has been our main compiler tree since the beginning of EDK II. When it says 0%, it just means it's even. It is the same size within a sampling error. Galileo, which is an IE32 full open source project. We picked this one because there's no like magic binaries lurking underneath the hood. This gives us pretty comparable sizes. There's still improvements to be made, but I didn't put the GCC4 numbers up because, sorry, they weren't that great. Some of them were really high percentage differences. And for early days on this gives us a good platform to work from to increase our optimization of ROM sizes, because flash space costs money. Okay, bugs. I like my friends at Git. We weren't that fond of their bug tracking system, but we have been using Bugzilla in different groups off and on, and it's become a pretty common platform across open source for bug reporting. So we now have bugzilla.tianocore.org. We recently got all security certificates installed on this, so don't worry when you click the link. If you click the link on the materials, it goes to the HTTPS version. And that was sitting on a temporary domain, but we have that resolved now. This is where we put everything. We put core issues, platform issues, and feature requests. So this is another part of our community efforts and our work towards like a more transparent process. Security issues. You're going to find them. Everybody's code has security issues. We're going to use a different process for this. And that is documented, but I'm going to sum up the 3 steps of reporting a security bug to TianoCore. One is you never use email to report a security issue. Second is you put them in a category called Tiano Security Issues. This is essentially an embargoed space that you can only see if you're in the USRT and UEFI, that's the security response team, or you are one of the people working on security issues or the reporter. That is so people don't publicly go find a security issue you haven't disclosed. This isn't going to become a database of 0 days. This is something we use to resolve things and properly work through issues before they become known. 3, you never use email to discuss a security issue. This is because, if you've been paying attention to American politics, emails are a thing. And sometimes they don't go to the places you think they're going to go. For point-to-point communications, if you sign your email, that's great. We use community email lists. It's a little harder. You can sign for authentication. Hi, I'm Brian. But it's harder to keep that in the contained group. And I don't want things that people are reporting against the core root of trust on your platform to get out before they are known to the, we have a known solution. Okay, plans. We have them. I'm not going to go into huge detail on many of these. There are a few I want to emphasize. First is the website. Along with being a validation nut, I'm a documentation nut. We could use more of that. We moved our system, our website system over to Git, and we're going to start using Git books a lot more. The idea that you make a document in like OpenOffice or Word or FrameMaker and you PDF it and put it out into the world as a spec, I don't print that much anymore. So paper formatting is not a big deal for me. I would like to have something simple that you can read on different devices or have an easier time contributing to. Open test cases. We had a UEFI Plugfest last week in Seattle and had a fairly long conversation about opening up a lot of the test process. Mike Kinney, who works with me at Intel, really wants to start moving open test cases into EDK II. So you have more of the test apparatus along with the thing you're using for the firmware. Open platforms, which is Leaf's big thing. ARM has actually been our biggest driver of opening up platforms. So right now, you have more open ARM platforms than you have as Intel. Now notice I'm not frowning when I say that, and you would think I would be. There are things that you can find on an ARM platform that wouldn't be revealed on an Intel and vice versa. So if I do all my full testing on just Intel platforms, I'm not going to find every possible issue I can get in a protocol. So from an open source standpoint at Intel, if they put a bunch of ARM platforms out and work out all these weird issues that I can't replicate on current hardware, that's better for me. That's kind of an open source thing. That's why I'm in favor of this. Now, of course, I'm inside my own company saying words I won't say on stage in Vegas. I might say them at the blackjack table at 11 in the evening, but I won't say them here about why don't we do more open platforms, and we are. So there are more examples of the Intel side going into open source over the coming months. And the next one I'm going to focus on a little bit more, which is releases on a regular cadence. We do snapshot releases typically every 6 to 8 quarters. Stable snapshot is basically, we tested this on a whole bunch of things. We like it. It's good. We know when you start working on firmware, kind of like you start working on something based on a kernel, you don't go off of that kernel and make significant changes once you start your core platform development unless there's a really compelling reason. So people lock in firmware cores pretty early in the design process. Because if you have unstable hardware and unstable firmware, that's a bad combination. You typically want stable hardware, unstable firmware, or stable firmware, and hopefully soon to be unstable hardware. But that release timing, that's long. That's a long time to wait. We want to get to more of a 2 per year release, maybe 4 if things are not going well. But from what I'm talking to people here at the conference, 2 stable snapshots a year seems to be a good time. And this will kind of be a cascading thing. Platforms will be where you reveal your issues, where you try out your staging branches. So things will flow from platform to staging to main branch to stable. The naming convention, which I might change because it's a little confusing, when things go to stable branch, we call them UDK or UEFI Development Kit releases, based on the EFI Development Kit 2nd generation, so we might rename that. But anytime you see UDK in front of something, it's going to be a stable snapshot. It goes to a particular Git hash, or it goes to a, heaven forbid, a zip file full of things that are based on that stable platform. So we want to get into more of a continuous requirements, fixes, validation, release cycle to make sure we're keeping pace. All right, we're talking about releases. We have one coming up. It's going to be early next year. When I say Q1, I don't mean marketing Q1, which is March like 30th. I mean like January. This is going to include a number of features. Again, the caffeine hasn't kicked in yet, so I'm not going to put them all down on the sheet. We wrote it down in a spec, so you don't have to memorize this. But we're doing a more generic stack for eMMC and SD cards. That's based on UEFI 2.6 work. There's a new memory attributes table. There's HTTP boot, along with the TLS. That's over IPv6. A RAM disk, which is important for the previous feature, because when you pull down that lovely Linux ISO, you want to cache it somewhere in memory. So that's what you can do in RAM disk. And you can preset URIs in the firmware. So if you're making a commercial product and you have the big emergency button that goes to automated recovery over the internets, when you push that, you already have a URL set and you already have your certificates pre-populated. So it goes to a known place based on known certificates. PI 1.4a, that's the errata for the under-the-hood packaging stuff. And we also get into EDK II implementation issues such as upgrading OpenSSL and getting to NASM, which makes me so happy. Okay, that is the facts and figures part of the show. Now, somebody at Intel thought it was important enough to put me on an airplane and send me here, so there must be some philosophical reason why this is kind of personally important to me, why I've been doing it for 20 years. It's not just because I like paying off my mortgage. Turns out I do. I'm a big fan of food. This trip has not helped that at all because of buffets. But I got into firmware kind of by accident. I started out in speech recognition. And in 1994 to 1996, getting your master's in speech recognition meant that you built something that was bundled with a Sound Blaster card. And it didn't work really well. One of my roommates had the problem of installing his speech recognition package on Windows 3. Mumble. And his roommate will walk through the room and go, "Shut down," from like across the kitchen, and the computer would turn off. So that was a bad idea. So I got out of it because it never worked like it would on Star Trek. Captain Kirk made that look easy. You just walk in and he would say something to the computer and it would work. It'd be perfect. So I got out of it because I didn't think it was going to work out that well. Thought I would spend 20 years working on something that was actually functional. Turns out that's the only timeline prediction I've ever made in the industry that's correct. And I make roadmaps all the time. But in 2002, I actually had my career choices validated by William Shatner. He was a guest speaker at IDF. And he went on this long rant about speech recognition when I asked him a question about what technology in Star Trek do you think will never get replicated properly. And I used speech recognition as the example. He ran it for 10 minutes about how it was a terrible thing. It never worked like he was supposed to because he always got hired to do the demo at the show. And it always failed. Probably something about the time in between phrases before it thought you were done with the sentence. And at that point, he looked at me and said, "Why didn't you fix it?" I said, "I couldn't. That's why I went into this." And he said, "Good job. Next question." So Captain Kirk validated my choice to go into firmware. So I've stuck with it for a while. You have all been asking this now for roughly 29 minutes. So let's get to the punchline. I don't care about building standards. I care about building infrastructure. This is fairly important because a lot of the work that we do, especially if you're into embedded systems, nobody sees what you do unless it breaks. So when people talk about UEFI on Twitter, do you think it's, "Yay, I had the best experience installing Yocto on my system"? No, they don't. They talk about the corner cases. So I work in a place where if I do my job properly, nobody notices it. I normally call this a stoplight problem. If I go in and I change all the stoplights from incandescent bulbs to LEDs, if I did the job right, only the nerds notice. Ooh, there's a lot of dots in there. That's going to save them about 28% on their power bills over a month-by-month basis. Most people just kind of go, "Oh crap, it's yellow," and speed up. I care about infrastructure. I care about having a stable platform so that when I take a trip to Vegas, I'm doing this and not sitting in the audience crying because somebody is doing a zero-day report on what I worked on. When I started working at Intel, I spent a lot of time in our DuPont, Washington office. Across from this is the Tacoma Narrows Bridge. It is an impressive feat of engineering. When I say the word Tacoma Narrows, most people don't think about this. This is the second version of the Tacoma Narrows Bridge. The first one, if you have the History Channel on your hotel television, sometimes you see this version. This is Galloping Gertie. This was the first version of the Tacoma Narrows Bridge, still at the time a feat of engineering, with one small design flaw. People tested the wind this way. They didn't test the wind this way. And it's on a river in a place that rains a lot. So it started torsion issues, I think is the term they used when I was briefly a mechanical engineering student. This didn't turn out well. And people don't care about infrastructure. They care about rockstar programmers. Woo, rockstar programmers. I played in a band in college. I played drums. So even if my band became famous, I was never going to be a rock star. Let's be honest. I was my own roadie. I would go and play a gig on Thursday nights. We'd open for a band that we really liked, and I would leave before their set was done to go back to the lab and finish simulations in MATLAB. I wasn't going to be a rock star. Now, I bring this up, and I apologize to my cohorts watching on YouTube. We did this to ourselves, specifically we, the people that paid me to be here. We created this impression that what you do in the industry, you have to do the big things, and you have to be like super famous and get invited to do better keynotes than this, and that's how you become the programmer. It's about flash, it's not about stability, it's not about the basic structure that things get built on. So everybody tries to do this, and they kind of skip a lot of the fundamentals. And the thing that does this the worst to me is the cloud. I'm sorry, I'm in marketing. The cloud. The cloud is always talked about in hushed whispers, and like, the cloud is magic. The cloud keeps all of our things. I'm building a cloud ecosystem to back up my cat videos. There was actually a guy at VMware at a conference that just kept doing hand motions with the cloud. It drove me crazy. But the cloud is this sort of like, it's this personification of something we've been doing for decades. Of course my stuff's in the cloud, i.e. it's on another computer, because I'm not an idiot, I back my files up. And the cloud is this kind of rock star that we've created. We want to think about all the cool things that we do, and we miss the fundamentals. Matthew Garrett's a friend of mine. We worked a lot together on early days of UEFI, and his hobby is finding IoT devices that haven't done their security well and publicly talking about how to break them. One of my favorite Matthew Garrett moments is him sitting in a hotel room and live tweeting hacking the lighting control system, to the point where he figured out the IP address scheme, figured out that the IP address was floor number dot room number, and kept opening and closing his boss's blinds because he knew which room he was in. That's the cloud. And there are three types of cloud, of course. There's the cloud, there is the fog, which I spent some time in Portland earlier this week. I'm familiar with the fog. That's how machines talk to machines. And of course, there is the smog, which is where everybody keeps their pornography, but I am not going to talk about that. What I do like about the community that I'm in is that we know about plumbing and we focus on plumbing. We think about this infrastructure as baseline. So Linux community for years has called it a plumbers conference. They acknowledge that up front, and that's where their best people go. If you want to go to a Linux conference, talk to a kernel developer, you go to a plumbers conference. I'm sad I can't go this year. There are people who've talked about blue collar coding. There are people who remind us that, you know, if the plumbing's not good, you get cholera. Yay, cholera. No, nobody's ever cheered for cholera before. So a wise man once said, firmware isn't sexy, it's plumbing. Okay, I said that, so skip the wise part. This is what we have to think about when we do any low-level work. And we have to think about it without any sense of shame or any sense of like, oh, I'm not going to be a higher-level programmer. I'm not going to write JSON code that goes to the cloud and fixes whatever problem with my thermostat. Plumbing is super important. At breakfast, I was talking with one of the Lenaro conference organizers, and he'd seen the presentation and said, oh, thank you for mentioning plumbing, and told me all the horror stories of his house plumbing, how he came back 3 weeks after a trip to mold because the plumbing leaked in the walls very slowly while they were away. Not a pleasant story to hear at breakfast, but anyway, this is kind of the example of doing the fundamental things right and being okay when they stay invisible and just structure works. People didn't care about plumbing. And then they moved to Flint, Michigan, and then everybody suddenly cared about plumbing. So when you say, I'm going to be a plumber, but I'm going to be a cool plumber, I'm going to be a famous plumber, I'm going to be one of the Mario Brothers, So when I talk to people of a certain age, hi, I'm of a certain age, you remember running around as a red, or if your brother got the Nintendo first, green-suited plumber. You were not a plumber. I mean, this is a plumber who primarily got famous for dealing with a primate that stole his girlfriend who threw barrels at him. None of this is plumbing. He goes to the wrong address. He breaks infrastructure. Mario and Luigi are the worst plumbers. They do none of their job, and they are somehow famous. So as a plumber, maybe they're not your role models. Because if you think you're these guys, you're probably these guys. I don't really think you want to end up in that position. You need to focus on what your job is actually supposed to be, which is making the infrastructure work. And that's what really I learned to love about doing firmware, is I got to work on this baseline that made it possible that when Windows 8 came out, the entire world went, maybe I should try Linux. And they could. They could just pick up the PC they bought off the shelf. For the most part, we worked some problems out. It's getting better. But they could just take that, throw something on a CD or a USB and try it out. And they said, well, I'm going to try Ubuntu. And they got on the internet forum and said they were going to try Ubuntu. And a lot of people yelled at them. And so they tried Debian. And so they tried Fedora. And by the time they got all that sorted out, they're like, well, yeah, this is pretty cool. And then Windows 10 came out. Maybe they went back to that. Maybe they didn't. The point is, this kind of stable framework means that you have more choices from a development standpoint. If this middle layer can be solid, if the firmware and the root of trust can be standardized, your work and your focus as a developer is either on one side of that layer or the other. If I do my job right, your work is making your product function. So you can focus on the cloud. You can focus on the things that people really buy your products for. A lot of people in the room make boards. Consumers don't buy boards. Consumers buy products. They buy experiences. And if everything below that is done properly, then their experience is maintained and they get what they actually paid for, which is consistent computing. The things that we're going to work on in the future aren't going to be like flashy laptops and gaming systems. They're going to be these kind of invisible infrastructure devices. They're going to be things that you talk to order pizza, or little beacons that make things work for you. They're going to be thermostats. They're going to be like the weird things that make that transparent, futuristic life possible. They're going to be the things that make Captain Kirk be able to talk to a computer and give him exactly what he asked for, even if he didn't quite phrase it correctly. So this is why we standardize things. So if we standardize the firmware, if we put out a good base layer for how you can do it in the open, I don't care if you build in the kitchen sink or the cool pedestal sink or that marble bathroom in my hotel room, which is really nice. I care that that pipe, that the baseline of this is what it's exactly supposed to be, that everything fits within that framework. So I don't care that another company can drop a sink on it. I care that it's stable so that anybody can drop a sink on it. So we talked about firmware, which probably wasn't what you were expecting after breakfast, but congratulations for sticking around. I just want to leave you with 3 thoughts about this. One is that the work that we're doing in TianoCore is the idea to make UEFI more open, so that what you rely on as that base, if everything above that layer is open source, I want to try to work on making everything as far down as possible open. Second is, this is a community-based effort. You're going to find things I didn't think of. You're going to find things Leaf and Mike and Andrew didn't think of. That's why open's good. You're going to see things from a different perspective. If I spend all my days in the trenches, you get to see what it's like at street level. And then that makes everything better. And third, it's okay to be a plumber most of the time. Thank you.
Okay, just a few announcements and we'll get going. You guys could switch over. Excellent, thank you. Okay, so the first thing is we're really excited to welcome a special guest, and that's Linus Torvalds is joining us for the next couple of days, so please join me in welcoming Linus. So he's an attendee here just like everyone else. You see him wandering into sessions and the things that interest him, and we should have a good next couple of days as we've been planning. There is a fireside chat tomorrow that Linus and Dave are going to host, and it's really based around your questions. So there is now, I am told, with great confidence, a box, a questions box out at the registration desk. So if you have any questions, and I'm sure many of you do, please just write them down, put them out in the box, and we'll include them as part of the fireside chat tomorrow. That should be a lot of fun. So today, every day is networking day here. I like that. I like the way that that's put. But today is actually officially LNG Day, or Linaro Networking Group Day, and there's lots of sessions this morning up until lunch around networking. This is also the third mini conference day, the third and final mini conference day. The mini conference today is about AOSP. I've heard really great feedback about mini conferences in the first 2 days. So it's sort of this new concept within Connect. It seems to really be working. If you're interested in AOSP, I encourage you to go to Grand Ballroom D after this, and that will go until lunchtime with some very interesting sessions there. If you haven't picked up your t-shirt by the end of the day today, or your water bottle, I think you probably don't want it. Also, Dave's puzzle. So take a look at the puzzle inside your program guide. If you have any thoughts about the puzzle, you think you can calculate an answer, you have a pretty good guess, you can turn those in over at the registration desk. We'll announce the winner or winners tomorrow, and fabulous prizes, of course, will be involved for all. Tonight at 7 o'clock poolside, outside, which should be really nice, we have the fabulous Viva Las Vegas Gala Dinner. We've used the same format that we did in Bangkok in terms of it's not a seated dinner. There'll be food stations and places to talk and chat. There will be chairs around to sit down in informally. So it should be a fun time. Also, we're encouraging everyone to dress up fancy. So if you have something fancy to wear, if you're capable of impersonating Elvis or even Liberace, we would encourage you to come and do so. If you're not and you don't have anything fancy to wear, that's just fine. You're just as welcome. But there will be prizes that will be awarded for those who find special ways to represent themselves in terms of dress, fancy dress at the event. Of course, at the event, it's also now our tradition to recognize those folks who have been involved with Linaro for 5 years or more now. And that's not just for employees, but also for folks in the community. So we always look forward to doing that. And then just to let you know that tomorrow is Demo Friday, as is our tradition since almost the beginning. I think since the beginning, actually, as far as I can remember. And because of the 96 boards availability, there are more demos than ever. We're really excited, and there are some really interesting demos. Food gets served during Demo Friday. It should be it should be the best Demo Friday we've seen to date in terms of both volume and interesting things that people have been doing with these boards and others. So be prepared for that tomorrow. One of the things that Robert Wolf and Chauvin have done, if you haven't seen it, we've been building the 96 boards community. So they've been hosting these 96 boards open hours on the network, and it's really been building up to the point where now almost 100 people are showing up at every one of these things. And they thought it would be interesting. Let's do one live here, since we're all here together. Let's do one live from Connect. So we'll be doing it live this afternoon, starting at 2 o'clock in this ballroom here. And so in addition to people on the network, we'll have people here live in the audience, yourselves and them, and we think it will make for a really interesting event. So if 96 boards is of any interest to you, you can ask any questions, make any comment, provide feedback. It's a really great community forum. I'd encourage you to be here. So I'm going to just turn it over to George to share with us. Qualcomm made a huge announcement this week, and it has wide-ranging impact, and George is going to sort of share some analysis of this announcement with us.
Thanks, Joe. So we've obviously been working with Qualcomm for a long time. They're one of our core members. We are very appreciative of all the support they've given us and the open source community. The Snapdragon embedded processor announcement was made, I think it was yesterday. And this is going to, I hope, have a really big impact. The exciting thing about this is that for the first time, Qualcomm are making their mainstream mobile devices available as embedded products with support for 10 years. And you can just go and buy them from distribution. And hopefully, as a result of that, there'll be great documentation and we can do some really interesting things with these devices. And as I say, for the first time, you can just go and buy them from Arrow one by 1,000, build anything you want. And I think some of the Dragon board, community board work we've been doing is really going to help this, because companies and makers and developers can take the software that we've built for the board and reuse it completely open source on the products they make. So yay, Qualcomm, well done. I think this is a great move. Thanks. If there's any more information, there's a bunch of Qualcomm guys here. Tia Cassette, who heads up this program in Qualcomm, is also available. Find her, ask her questions, and I'm sure she'd be happy to talk to you. Thanks.
There's also a really good announcement and an interesting and relevant announcement for everybody from ST Micro and Christian Bertin, who's going to share a little bit of insight with us on that.
Good morning. It works. Yeah. So we are announcing the availability of these tools called Otto Tools. We presented them at the last Connect in Bangkok. These tools are working on Linux for the C, by default for the C and GCC and LLVM compilers or cross compilers. The goal of these tools is to automatically find the best configuration flags for achieving the best performance or the best code size or the best trade-off between performance and code size for a given program with a given set of inputs. So in fact, it's based on the machine learning, and it uses a tool called Pirut, which does system calls in interception to change the flags of the used by the user without the user knowing that this is done. The original aspect of these tools is that they do not require any change to the build system of the program, any change to the source of the program to find the best configuration file, the best configuration flags. So to illustrate that, I show you the results of on this slide of an exploration on I think it's on GCC. It's not written there, but it's the optimization of the zlib library of the Linux distribution. And you can see on this slide that there are many points which correspond each time to a new configuration set of flags. You can see in the middle of the slide, you have the reference point, which is the value, the state of the program when you don't change anything, when you just make and run. And you can see that if the code size is reduced, it's getting on the right. If the code size, if the code is faster, it's getting towards the top. And we can see here the best performance trade-off between code size and performance. And another observation is that the default value of O3, OS, and O2 are not very well set up in this case. So that's it. The code is available on GitHub at the previous at the address written on the previous slide, and everything is in place for receiving contribution. We have a CI loop with tests, and we have anything in place for receiving pull requests. So that's it. Enjoy, and if you have questions, don't hesitate to ask me.
Okay, and just to close us out, I thought that since we are in Vegas this week, and we are all mathematicians because software is math at the end of the day, right? That we just had to take a quick look at some of the aspects of gambling in Vegas. So why don't we do that? So table games, by calculation, are clearly have much better odds. If you're going to play anything, play one of the table games. They may be a little bit more intimidating because there are live people involved and there are other people playing, but they have much better odds than slot machines. And in general, if you look at all the table games, the best odds of winning, and this has been analyzed to death over the years, is really blackjack. There's really only a 1% edge that the house has in blackjack. So you have the best chance of winning in blackjack. In general, it varies a little bit by by casino depending upon the rules or the number of decks they use, but 1% is generally considered. Craps or dice is the next. It's a very complicated game. I tried to learn a little bit myself tonight, and I know there were some people that were mastering it out there, and it's a pretty interesting game. That's the next best. It's about 50-50. Roulette is the third best odds, and you get 36 to 1 if you can guess the number, but if you just bet red or black, it's almost 50%. Of course, it's almost 50% because the house also has to keep something as well. And slots are interesting because we have, I think we all have experienced this week getting up at 7 or 7:30 in the morning and seeing little old ladies with walkers at the slot machine smoking their cigarettes at these crazy hours, right? And slot machines are actually the worst from an odds perspective. And Wheel of Fortune, which is a show in the U.S., I don't know if that translates to other countries, but the Wheel of Fortune slot machine by far is the most popular slot machine of any slot machine in the history of slot machines, and you'll see a bunch of them out there and at every casino. But they're also set up so that they're usually the worst odds. If you're going to play a slot machine, that's really not the one to play. And there's a law in Nevada that the slot machines have to pay out at least 75% of what they take in. So they can't rig the slot machines completely against you. The worst case is it's going to pay out 75%. And the other interesting thing here that I found was the more they can adjust, of course, the odds on winning and what you win and how often you win. And the more money you put in, so in other words, the slot machines that take the higher denominations, $1, $5 or more, pay out more than others. And the other thing that you'll notice here in terms of comparing the different denomination slot machines is you don't get as good a payoff if you go down to the Strip and some of those fabulous bright casinos like the Mirage or Caesars or the Bellagio and whatnot. Those don't pay out as much as the slot machines will in locations here in North Las Vegas. And these are some of the facts. And you can see there's a few % difference between what goes on down there and what goes on here. So one of the things you'll find, and you can see that out there, is you don't get a lot of tourists here, but the locals, when they go to play, and they do play, they're going to go to a local casino because they know they're going to get better odds than they will down at the Strip. So that's just a little bit about some of the aspects of the games that are going on here as we have our meetings, and it gives you a little bit of background. Anyways, so that's it for today. Remember, there's 7 o'clock tonight at the poolside, the gala, and tomorrow we're going to start about 15 minutes early. So we're going to start here tomorrow morning for our last day on Friday at 8:30. Have a great day, everybody. Thanks.
I know I want to take me home.